Python is a versatile and user-friendly open-source programming language known for its simplicity and power. With high-level data structures and an elegant syntax, it caters to developers of all skill levels. Ideal for scripting and rapid application development, Python spans various domains, including web development using frameworks like Django and Flask, data analysis and visualization through libraries such as Pandas and Matplotlib, as well as machine learning and artificial intelligence, leveraging popular frameworks like TensorFlow and PyTorch. Its ease of use, extensive libraries, and active community support make it a go-to language for automation and AI applications. Python's versatility is evident in traditional machine learning tasks and cutting-edge deep learning projects, facilitated by powerful tools and frameworks. Python is a dominant language in artificial intelligence, AI, due to its extensive libraries and frameworks tailored for machine learning. Prominent examples include TensorFlow, PyTorch, Keras, scikit-learn, and NLTK, Natural Language Toolkit. These libraries offer pre-built functions, streamlining the implementation of complex AI algorithms. Python's thriving developer community actively contributes to AI-related libraries, providing support through forums and sharing abundant resources. In the realm of data science, Python is popular, offering robust tools like NumPy, Pandas, and Matplotlib, widely used for tasks such as data manipulation, analysis, and visualization. Its simplicity and expressiveness make it ideal for developing machine learning models, facilitated by high-level libraries such as scikit-learn, allowing for quick experimentation and prototyping. Python has emerged as the go-to language for deep learning projects, notably with TensorFlow and PyTorch, offering efficient tools for building and training neural networks and enjoying widespread adoption in the AI community. The user can run Python programs in two ways. First, by typing commands directly into the Python shell, and second, by executing programs stored in a file. The Python shell refers to an interactive environment where users can enter Python commands and observe immediate results. On the other hand, a Python script is a collection of Python code saved in a file with a .py extension. In contrast to the interactive nature of the Python shell, a script is a file containing a sequence of Python statements executed when the script is run. Python scripts are particularly useful for larger programs and projects, enabling users to organize and structure code into reusable and modular components. To access the interactive shell, users can type Python or Python 3 in their terminal or command prompt. In this shell, users can execute Python statements, perform calculations, and test code snippets interactively. Python scripts are created using a text editor, and once created, users can run the script by entering the command Python or Python 3, followed by the script file name as an argument. This approach allows for the execution of more extensive and pre-written code, enhancing code organization and reusability. In Python, a variable is a name assigned to a value or object within a program, enabling the storage and manipulation of data. Identifiers, which are names given to variables and functions, must start with a letter or underscore, and digits cannot be used. Identifiers also cannot be keywords, which are reserved words with special purposes in Python. Examples of keywords in Python 3 include true, false, none if return for, from, import, etc. Unlike some other programming languages, Python does not require explicit declaration of variable data types. The language dynamically infers them. Python's dynamic typing allows for the reassignment of variables to different data types during code execution. The most common data types in Python include integers are whole numbers without decimal points. Floats are the numbers with decimal points or in exponential form. Strings are ordered sequences of characters enclosed in single or double quotes. Boolean represents either true or false. Lists are ordered, mutable collections of items. Tuples are ordered, immutable collections of items. Dictionaries includes unordered collections of key-value pairs. Each of these data types serves specific purposes, and further details about them will be explored in subsequent slides. In Python, the string data type is fundamental and versatile, used for representing sequences of characters. A string is essentially a collection of characters enclosed within quotes. It allows you to work with textual data in various ways. It's important to note that strings in Python are immutable, meaning once a string is created, it cannot be modified directly. However, you can create new strings with modifications. Strings support various operations like concatenation, indexing, and slicing. The plus operator is used for concatenation, and the asterisk operator serves as a repetition operator for strings. Individual characters in a string can be accessed using indexing, starting from index 0, and substrings can be extracted using slicing. Additionally, you can use comparison operators to compare two strings character by character. The string class in Python provides various built-in methods. For instance, you can test, convert, and search strings. It's worth noting that Python's string handling capabilities make it a powerful tool for a wide range of applications, from fundamental text processing to intricate data manipulation and analysis. In Python, a list is a mutable data type utilized to store a collection of items. It serves as a fundamental data structure, playing a crucial role in numerous programming tasks, ranging from straightforward data storage to intricate data manipulation and analysis. A list can accommodate elements of different data types, and it even has the capacity to include other lists. Lists maintain order, preserving the sequence in which elements are added, and they facilitate indexing, slicing, and various operations on the elements. Lists are created by enclosing a comma-separated sequence of elements within square brackets. Elements in a list are accessed using indexing, starting from 0. List elements can be added, modified, and removed, supporting operations like concatenation, repetition, and length retrieval. Python lists come with built-in methods for common operations, such as appending, popping, inserting, reversing, and sorting. Additionally, lists can be nested, enabling the creation of multidimensional structures. Given their flexibility and ease of use, lists are extensively employed in Python for various purposes. They provide a versatile and convenient way to work with data, making them an integral part of AI projects. In Python, a tuple is an ordered and immutable collection of elements. Much like lists, tuples share similarities, but a crucial distinction lies in their immutability. Once a tuple is created, its elements cannot be modified, added, or removed. Tuples are defined by enclosing elements in parentheses and separating them with commas. This immutability feature becomes particularly useful when maintaining the integrity of data throughout a program's execution is crucial. In addition to immutability, tuples support various operations that are analogous to those of lists and strings. Slicing, indexing, concatenation, and repetition operators work in the same way for tuples as they do for lists and strings. This provides a consistent and familiar syntax for manipulating elements within tuples. Understanding these operations and their consistency across different data types makes tuples a versatile choice in scenarios where data integrity and immutability are paramount. In Python, a dictionary is a powerful and flexible data structure that facilitates the storage and retrieval of data through key-value pairs. Each key in a dictionary must be unique, serving as a distinct identifier associated with a specific value. Dictionaries are defined using curly braces and support modifications through operations like adding, updating, or deleting key-value pairs. When accessing a dictionary, if the specified key exists, the associated value is returned. Otherwise, a key error exception is raised. Looping through dictionary elements can be achieved using A for loop, enabling the traversal and manipulation of key-value pairs. The len function provides the length of the dictionary. Python offers several built-in methods for efficient dictionary manipulation. Some commonly used methods include clear, copy, get, items, keys, values, pop, and popitem, among others. Understanding and leveraging these dictionary methods enhances the flexibility and effectiveness of working with dictionaries in Python. In Python, Control statements are essential for directing the flow of a program based on specific conditions or iterating over sequences. Conditional statements, primarily encompassing if, elif, and else, allow the execution of different code blocks based on the evaluation of a given condition. Looping statements, notably for and while, provide the capability to repeat a block of code multiple times. The while loop facilitates the repeated execution of a code block as long as a specified condition remains true, while the for loop is instrumental for iterating over sequences like lists, tuples, or strings. Control flow statements, including break, continue, and pass, augment the program's execution control. The break statement terminates a loop prematurely. The continue statement skips the remaining code within the loop, and pass acts as a null operation. These control statements collectively provide essential tools for constructing flexible and responsive Python programs. They empower developers to dynamically manage the execution flow based on conditions or efficiently repeat tasks, contributing to the versatility and adaptability of the code. In Python, a function is a block of organized, reusable code designed to perform a specific task. Functions provide modularity and abstraction, enabling the breakdown of a program into smaller, more manageable pieces. To define a function in Python, you use the def keyword, followed by the function name, parameters, if any, a colon, and an indented block of code representing the function body. When calling a function, you use its name followed by parentheses. If the function takes parameters, you pass values within the parentheses. Default values can be assigned to parameters, making them optional for the function call. Additionally, functions can utilize the return statement to send a result back to the caller. In cases where no return statement is used, the function returns none by default. It's important to note that variables defined inside a function have local scope, meaning they are only accessible within that function. On the other hand, variables defined outside functions have a global scope, making them accessible throughout the entire program. In Python, file operations are crucial for reading from and writing to files. To interact with a file, you need to open it. The open function is used for this purpose, taking two parameters, the file name and the mode, read, write, append, etc. Once the file is opened, you can read its contents using methods like readDone, readLine, or readLines. For writing to a file, the write method is utilized. It's essential to close a file after finishing work with it, achieved by calling the close method. Using the with statement is a cleaner way to handle files. It automatically takes care of closing the file, even in the presence of errors. These represent fundamental file operations in Python. Remember to close files after using them to ensure proper resource management. Exception handling in Python is a mechanism that enables you to gracefully manage errors and unexpected situations that may arise during program execution. Exceptions are events that disrupt the normal flow of a program. Python offers a robust exception handling mechanism to address these situations. The key components of exception handling in Python are try and except. The try block encloses the code that may raise an exception. If an exception occurs within the try block, the control immediately transfers to the corresponding except block, where the code is executed to handle the exception. The rest of the code after the exception is skipped. Exception handling in Python provides a structured approach to dealing with errors, enhancing the robustness and maintainability of your code. It enables you to gracefully manage unexpected situations and incorporates mechanisms for cleanup operations, improving the overall reliability of your programs. In Python, a module is a file containing Python definitions and statements. The file name is the module name with the suffix .py added. Modules allow you to organize your code into separate files, making it more modular, reusable, and maintainable. Let's say you have a file named mymodule.py. You can import the module into another Python script using the import statement. Alternatively, you can use the from import syntax to import specific functions or variables from the module. When you try to import a module, Python searches for the module in the current directory, directories listed in the Python path environment variable, and standard library directories. Python comes with a rich set of standard modules in its standard library, covering a wide range of functionalities. Some examples of standard modules in Python are the OS module, Math module, Datetime module, Random module, and JSON module. These are just a few examples, and the Python standard library includes many more modules covering areas such as file I/O, regular expressions, networking, and more. You can explore the official Python documentation for a comprehensive list and detailed information on each module. A package in Python serves as a mechanism for organizing related modules within a coherent directory hierarchy. This structuring capability proves invaluable in managing large code bases, enabling the grouping of functionalities that are logically related. A package is essentially a directory equipped with a special file named init.py, and it can further encompass subdirectories and modules. Modules within a package are imported using the dot notation. Furthermore, PIP stands as the dedicated package installer for Python, functioning as a command line tool. Its primary purpose is to facilitate the seamless installation, management, and removal of Python packages sourced from the Python package index repository. This repository housing a vast array of software packages that have been collaboratively developed and are actively maintained by the Python community. This collaborative collection of packages significantly enhances the versatility and functionality of Python applications. Before we conclude this Python course, I want to express my appreciation for your dedication and enthusiasm throughout this learning journey. In the realm of programming, theory lays the foundation, but it's through practical application that we truly solidify our understanding. So as you continue your journey with Python, remember that the practical skills you are acquiring here will set you apart. They form the building blocks of your proficiency, enabling you to confidently navigate the challenges that await in your coding endeavors. We encourage you to keep exploring, experimenting, and applying what you've learned. Python is not just a programming language. It's a gateway to innovation in the exciting and ever-evolving landscape of artificial intelligence.